Today we're going to present to you our journey to RKE2. I'm assuming that you're all here because you as well are going to be making that journey. And so just to start, my name is David Batello.
Yeah. My name is Karthik Appala and I'm a Principal Cloud Engineer at Fidelity Investments.
So this is my team. This is Karthik, he's on my squad. And in the back of the room is Pavan Nanduri, he's also up there. But the rest of the team are largely responsible for the success of making this RKE journey to RKE2. And as you all know, it takes a village to kind of accomplish some big tasks. And I think that Nicole Malakowski on the keynote the other day really kind of summed it up really well. And I just think that it's really important to just emphasize that, you know, without this great team, you know, we wouldn't have been able to do this all together. So I'm sure you all have great teams as well, but I just wanted to make sure you all, without them all being able to be here, I just wanted to make sure that it was really clear that it's without them, this wouldn't happen. So we're here to show you our journey pretty comprehensively. We're going to do start to finish. How we migrated our on-premise Rancher applications from RKE1 over to RKE2 across 4 independent zones across 2 regions. For our architecture, we have Raleigh and Omaha, and we have zone 1 and 2 in each of those environments, and then we have non-production and production. But before we get into all the details of that, I wanted to just tell you a little bit about Fidelity and our ecosystem. And currently at Fidelity, we have 3 Kubernetes service offerings, which we've branded as FidQ. And in the public cloud space, we use Amazon, which we've termed FidEKS. And in Azure, we have FidAKS, and I bet you can guess what it's called on-prem, FidRKS. And so we try as best to really keep all 3 of these platforms in parity as best as possible. And in our journey, we really had to make sure that we were making sure that these platforms stayed in sync the entire time. And so right here, this is our agenda for today. We're going to try to cover all this as quickly as possible. I'm going to start with the problem statement. The analysis, the in-depth analysis that we went into. We'll talk just a little bit about some of the goals that we had in order to achieve this task. We're going to go through the planning process and what was involved in that. And then I'm going to turn it over to Karthik, and he's going to go into the design and the tooling, the execution flow of how we made all this happen, and then hopefully we'll get to some lessons learned and tips and tricks that we might be able to share with you. So to start off with, our journey to RKE2 actually started about 8 months after we went live with RKE1, which is around the end of 2020. And that was actually when the Kubernetes community announced that they were officially deprecating Docker as the runtime engine. And they were moving forward with exploring what was going to be that replacement. And it was around that time that SUSE, or at the time was Rancher, they used this as their opportunity to start to build out what was their new architecture, which is RKE2, and the framework based on cluster API with containerd, and also providing some new CNI options like Cilium into what we have today, which were all really good changes that were made, strategic decisions that positioned the Rancher product for a future in alignment with the Kubernetes community. But of course, for customers like all of us, this presented us with a considerable number of questions and challenges and problems to solve. And some of those questions that right away, as the architect for the platform, were in my mind were how long will it be before the Kubernetes community comes out with some sort of feature or change or paradigm shift that is going to prevent us from delivering this to our customers. And so for us at Fidelity, we are in an area where all of our business units are pretty much responsible for their own. We don't control the continuous deployment of their applications. They are on their own. They deploy to all the different platforms based on their needs. And so it really kind of presented a large challenge to a large financial organization on how we're going to get them over from one to the other with all the different work streams of effort that were going on within those businesses to provide value that really meant something to customers other than just an upgrade to a platform. So, how are we going to do this was to first, talk about like whether an in-place option was available. And I'm sure you're all thinking the same thing, like, oh, well, that would have made sense, right? But, there was so many complexities in the architectural shift that, we're going to talk about this a little bit, but, it just seemed like, that was going to be a big problem. Like, could we do that? Well, couldn't we? What tooling options were available to us? Were we going to have to write everything by ourselves? Was there open source community projects that were going to make themselves useful to us to make this happen a lot easier? Would we have to build out parallel platforms? Would we have to buy more hardware? Would we have to expand the capacity footprint of our platform from a compute standpoint, networking, storage? There's a bubble involved here that has a real cost. And so in doing this, we had to evaluate all that as well. And then the big question that was probably foremost in front of all of us was, how long was SUSE going to support RKE1? What was our runway? Like, what was the path? Now it's still in support, and they've extended it again. But I am a little bit nervous, and I couldn't wait for that to happen. I didn't want it to come before me, and I had to hurry down that path. So, knowing all these things were possibly going to happen, I had to protect the platform and move as quickly as possible. And that led us to the next phase, which was analysis. And so one of the first things that we wanted to do was what I was talking about was evaluate the in-place option. Was that actually feasible for us to do? And so we targeted looking at first the Rancher Manageable Local Cluster and looking at the possibility of doing an in-place upgrade, understanding RKE2 and its installation, and whether we could kind of do it in a way that would allow supporting downstream clusters with RKE1 and RKE2, and then eventually getting them to RKE2. And so we did what was an in-depth POV on this for a short duration, but long enough to figure out that this was probably something that was going to become too risky, too intermingled with the various differences in the installations. And at the end of the day, the next question was like, how do we get out of this once we get into it? So, that was at the point where we decided like, okay, this ain't gonna work. We're gonna have to do probably parallel platforms and a re-platform of some sort. And, the path forward was the next step was to do like an impact assessment. Okay, so what does this mean to all of our code base? What could be salvaged? How much can we reuse of our existing automation that was operationalized and managing our current RKE1 platform? And could we leverage that for RKE2? What are the add-ons that we were deploying that were going to change? What can be reused? How is it going to affect our APIs? With Cluster API and the native RKE1 API that was built, we had to kind of identify what those differences, what the payload's going to look like. Were they going to be the same? Were they going to be different? And would we have to kind of accommodate those changes? Also, you're kind of looking at it from the perspective of what's the best practice here? Like, do I want to carry old practices over and bring them over to RKE2, or do I just want to bite the bullet and kind of redesign some of that while we're doing this, right? And then the next thing that we had to do was, which was in partnership with SUSE, and we did a deep dive, right? So we wanted to really understand RKE2, the nuances of it. Like I said, architectural difference, cluster API, security issues, as an opportunity to replace Flannel. We wanted to kind of take a look at eBPF and Cilium. What was the maturity around Cilium? What was the performance impact, right? All these things were kind of leading us in the direction of doing this deep dive on site with their consulting services engagement. And we spent probably 5 days in a room with them going through all the nitty gritty of what were we going to expect, any gotchas, was anybody else doing this? You know, had they had an experience on it? I don't think so. I think we were one of the first people, so it was really new to them as well. So we were kind of like pioneering this effort, and they were really helpful to kind of like making sure that we had all the tools available to us to make good decisions. And it was at this point in time where we knew that we were going to have to move forward and build out a new platform and to start to, make some decisions, right? So as part of this, we had to establish some goals. And moving forward, one of the mandates that was given to me was, hey, Dave, there are all these various business initiatives going on that provide real value to customers. I need you to do this without getting them involved. So, that's a great thing. You know, everybody wants to do that, but it was so complicated at the time for us to think about that. So we had to start to, identify again what would that look like and what were the goals that we were going to put in place, knowing we were going to have to build out a parallel platform. Again, identifying the code that we could reuse, we decided that we had this awesome GitOps model for managing our projects and our roles and our users and resource quotas on RKE1. And when we stood up RKE2, we said, well, once it's up and running, let's do just a complete sync so that they're always in sync. We just added them into the list of nodes that we were going to update. And so all the users, no matter if they were removed or added or projects, it was always going to be in synchronization even though there was nothing there yet. And so we kind of like use this as an opportunity to kind of burn in the platform as well. Make sure that the new platform was operational and that everything was looking good. And so another one was like LTMs. So for our architecture, we had a single LTM that was responsible for ingress, and we had another one for API. And customers weren't going to want to change anything. Again, the mandate, right? Don't make them do anything. So that was going to be a challenge for us. Karthik's going to go into the details of how we ended up doing that. But that was a goal, like reuse everything in the networking load balancing space and figure out how we can kind of manage a swing over to the new platform. Backups, looking at how we would get all the data and all the objects over. We knew that we were going to have to clone everything in some way or another, namespaces, identify cluster scoped objects, figure out what we wanted to filter in the cluster scope, what we wanted to keep nice and pure on RKE2 and not carry over junk from RKE1. And then I talked about the zone cutover. So originally we were going to do like a cluster by cluster, but we have over 100 clusters. And so I was like, no, we're going to have to do this like all at one time. We're going to have to do a zone at a time. So it ended up being 6 weekends of cutting over. Obviously, touchless, right? We wanted to make sure that it was idempotent pipelines that were going to be touchless. Hit the button, go. And if it fails, hit it again, right? We wanted to pick up where it left off, be idempotent, and not break anything in the process. Also, we have this very strong philosophy around testing. Hopefully you do too. So building out like a sample application that was going to go along the way and do various validations at every stage of the game, acting almost like an application that the customer had deployed. And so we built a robust test suite around this. And it was built on PyTest, and it had markers in it so that it knew at every stage of the game, we're going to run this set of tests, and we're going to make sure that those validate before we move forward. And then, of course, I just mentioned it before, but again, I reemphasize, no application changes. We just wanted the business units to get on the call with us after we were done, validate their applications, give us the thumbs up and say, everything looks good, and then we would have like a no-go call of whether to move forward and not back out. So then the planning phase came into play, and this was really a massive project, right? So plan's worthless, but plan everything, right? Eisenhower said this as the supreme commander of the Allied forces during World War II. What did he mean? Well, likely he meant you got to have a plan, but likely it's going to break, and you're going to have to do some sort of a replan or reiteration of that plan as you go through it. And that's where retrospectives come into play. We really wanted to have, after every single weekend, a really defined retrospective around what went well, what went bad, what are we fixing, what broke, and continuously improve on that so that by the third or fourth time, we were just going to walk away and let it do its thing. So that was part of the planning. communication is very important. We have, like I said, this really decentralized relationship with our business partners. And so we really had to over-communicate. Our product management team was really critical in that, making sure we had like every avenue of communication so that they were informed of what was going to happen, the change process, and so forth. Analysis. So we were going to do CNI replacement. We had to do an in-depth performance test. We had to figure out what the CNI was going to benchmark against flannel. We had really great performance out of flannel, even for our size. We never ran into any degradation, but we wanted to make sure we at least had the same or better. And then we wanted to mark what features we were going to use, which ones we were not going to use, or maybe do as part of phase 2. So we came up with like a list of what that would look like, and we had to do it across different operating systems as well. So that was a little bit of a time sink, but it was worthwhile in the end because we did run into some issues that we had to identify. Characterization of data replication. So in change window, you got to really figure out how much time you have to get this all done. When you're talking about terabytes of data, we didn't have Longhorn. I went to a session yesterday that had Longhorn, so that helped them out tremendously. The SUSE product was, helpful to them. We didn't have that, so we had to come up with a different way of doing it. Let Karthik talk about that as well. But I think we were pretty creative about it. The simulation of the application behavior, again, testing along the way, and logging and metrics. So obviously you have 2 platforms up at the same time. You're trying not to interrupt service for those customers that are getting their alerting and the monitoring and the dashboards and the tracing. And so we just had to make sure that when we brought up this new platform, there wasn't going to be this mixed messaging in the logging, in the metrics, in the dashboards. So we had to come up with like a tagging solution between the 2 platforms that would make sense. So all this planning was really critical. And I'll just, before I turn it over to Karthik, he's going to do the deep dive on this. I'll just say that we spent 6 weekends doing the execution piece. He's got 20 slides, but we spent 14 months doing the planning and preparation. So it's kind of just to show you how much effort goes into the actual planning and preparation for the eventual change. I think that we can all agree that that's kind of where the meat of it is. So with that, I know I went fast, but we have a lot to cover. I'm going to turn it over to Karthik.
Thanks, Dave. Hopefully everybody can hear me. So a quick question to you guys. Whatever Dave said now so far, do you guys think what is the time frame that we did it across? Any rough time frame 2023, 2024? Any time frame guesses? We did it in 2023. We started this journey in 2023 and we built the first RKE cluster in Jan 2024 and we started the migration in March. So that's how old this is, but still it is relevant. I'll explain how, right? So we have lots of clusters. Like Dave was mentioning, we have 6 zones, 6 rancher managers. Inside each rancher manager, we have tens of clusters, each cluster having hundreds of applications in it, right? So if we have to migrate that many applications, taking advantage of what's so called in the earlier terms, everything which used to be a code in application, now being a configuration in Kubernetes, the complexity has shifted definitely from app to the Kubernetes platform, right? Now, migrating the applications that are taking advantage of these cloud native, Kubernetes native features, right? It's very difficult. And if you have to do it over and over and do it for multiple clusters, we need a rock solid automation, right? And then, but there's this unknown thing that our platform is also hosting other platforms. Say for example, we host Kubernetes platform, but that Kubernetes platform hosts something like Jenkins, something like Kafka. We don't know what goes in there. We don't control it. We control how they do it, but we don't control what they deploy in it. So the application part of it is unknown to the platform team, right? So we don't know, we may fail, right? We want our automation to be able to bring it back to the state where it was earlier in a click of a button. We don't want to be having an application unavailable for a longer period of time. That's one of the major goal for us. While we are building the migration automation, we wanted it to also handle the backout gracefully. And now these are the things that you're seeing: secrets, certificates, observability, security, governance, resources. These are all the integral part of the application management, right? So now, say for example, being a production grade Kubernetes platform, we say secrets should not be stored in the Kubernetes cluster. It has to be external. Now we have a Kubernetes cluster that's reading secrets from a particular place. We wanted to migrate an app. We have to make sure that the new home for that app should also be able to pull the secrets from the same location. How do we do that? That's one of the questions that we have. Certificate management, right? So that's big part of in accessing and in the application availability, right? Say we wanted to make sure the certificates are good and are in align with what they are at home earlier, right? So observability, like Dave was mentioning, for some period of time, even though there were no applications running on RKE2 cluster, there were two platforms which we were managing. We don't want the logs or metrics to be confused by what's there in RKE1 versus what's there in RKE2. So we use the tagging concept basically to say like what's RKE1 and what's RKE2, and at the end we flipped the bit so that there is no loss of logs that they felt, there is no loss of metrics that they felt, it was all seamless, right? And security and governance, if you guys notice it, ensure gatekeeper does not block non-compliant resources, anti-pattern, right? We want gatekeeper to block the non-compliant resources, but what is it? These clusters, the RK1 clusters were not built recently, and then the gatekeeper constraints kept growing. On day one, we don't have the same constraints as day 365. The constraints kept growing, and the applications might sneak in or might not be complying for the oldest ones that are deployed recently. So for us, if we have to move the applications, we also have to make sure that gatekeeper does not block non-compliant resources on the new cluster, because we wanted to bring like to like all applications. And resource quotas, like Dave was mentioning, we have a GitOps model and we have a controller, custom controller that we have written that kind of syncs it between the Git, and now we have to make sure we have the right amount of resources for at the right time on the RKE2 cluster, and so that the migration is seamless. Last but not least, applications are two types, like all of you know, stateless and stateful, and we also have to migrate the data which we don't know what it consists of. So that's a major piece, and we wanted to make sure how consistently we could migrate the data. And so these are all the things that had questions, and these were all the things that kind of helped us in designing, or these are all the things that we kept in mind while designing our automation. And the principles simply to use open source, let it be fully automated, ease of use, everything as code, collaboration is key. I'll explain what that means in the next slide. So this is our execution and tooling. I'll just give 2 seconds for all of you guys to take a look at it. What is it, right? I see nothing different, right? We know all of this. That's the beauty that I wanted to say. We didn't use any flashy tools. Everything that's out there, everything that's open source, we built it on top of the tools that all of us know. The flow, every green mark that you're seeing is the step, individual lowest denominator that we could break it up, and all of those were individual Jenkins pipelines, and we had an orchestrated pipeline on top of it which triggers these as child jobs, so that we could control which one to trigger and in which flow. Just in case if it failed, say for example, just in case backup failed, I don't want to run 1, 2, 3, 4, I have to start from 5th, and that's how we used an orchestrator pipeline on Jenkins, triggering these as child jobs, which helped us with the idempotency as well as backout capabilities, all of it, because it's orchestrated. We know what we wanted to execute and how, right? Now let's go into details about the execution flow, right? Step number 1, preparing RKE to cluster for the migration. So first thing that we have to do is make sure that there are no new applications that are being deployed on RKE1. There should not be any delta after we take the backup and if there is anything that gets deployed. So first thing that we did was enable the RKE1 in the read-only mode. That kind of gives us like, okay, we know this is it, right? Still, people will be able to access their applications. Access meaning they will be able to see, get the pods, logs, everything, but they won't be able to deploy anything net new. That we control using our GitOps workflow that Dave was mentioning. It's just a flip of a button. We just switched the roles there and everybody was put into read-only mode except us. Next thing, on the RKE2, we disabled our platform add-ons. There are a bunch of add-ons that we have, and we had to characterize and identify what mutating webhooks will mutate the object right after the restore and will change the application behavior. We don't want any variables. We want like to like. So that's why we disabled our add-ons like gatekeeper. We disabled gatekeeper because it should allow the non-compliant resources also while coming back after the restore. We disabled the cert manager because after the ingress resource is submitted, we don't want cert manager controller to do anything. We don't want it to be. It has to be like to like for us. Similarly, autoscaler. We don't want to spend time and scaling up and scaling down and stuff like that. We want it to be fixed. There has to be no variable during this point of time so that we can restore the objects like to like from RKE1 to RKE2. And then third one is basically disable the scheduled well-row backups on the destination cluster. That's because just to avoid any confusion, right? That's it. Now, the other thing is secrets management. Next important thing is preparing or linking the path between the RKE2 clusters to Vault. In Fidelity, we use Vault for the external secrets management, where we use the webhook to kind of pull the secrets into the applications. Now, in Vault, what happens is we have to probably, I'm not sure if you guys are familiar with it, but we have to register the cluster with Vault. That kind of gives something like auth method, and then we have to register the namespaces and the service accounts. That kind of creates the role inside that particular cluster, which will be then mapped to a policy. So that way, when a service account inside a Kubernetes pod requests a secret, it knows whether it has to give the secret to it or not. Now, we did this for RKE1 and they are good, but we have to do the same thing for RKE2. So here the challenge is query the Vault, find out for each cluster how many roles are there and what is the configuration that is associated with it, what namespaces, what service accounts, what policies it is all associated with, and now get all of these details, use those details and create the similar link for the RKE2 cluster. Now, when we did that, what happens is once this is all pre-step. We haven't backed up or we haven't restored, right? This is all the pre-step. Now we establish the connection with Vault for the RKE2 clusters also, so that when the applications are restored, they are good to get the secrets. Now, we have seen this, right? It's classic. kubectl. It's classic, but nothing flashy or nothing fancy. For the cluster object migration, we use kubectl. Velero can also be an option, but the problem that we faced with Velero was, one, RKE2 and RKE1 has different CRDs, and we didn't want to bring on the tech debt onto the RKE2 platform. So that's one thing, and we don't know what CRDs our customers has deployed, and we have to bring in what we need to bring in and what we should not bring in. And cluster roles, like we know, Rancher associates and pushes the cluster roles and role bindings using the UIDs, role UIDs, and those UIDs will be different because we are migrating it to a different Rancher manager endpoint. So we have to migrate the cluster roles that are specific to the applications but not specific to the Rancher RBAC. So this fine granularity is missing in Velero, and that's why we could not use it. So we thought like, okay, let's leave it, let's use kubectl, let's dump everything that we wanted to, and then as a big YAML, store it to the S3 and download it onto the, using a Jenkins pipeline, download it onto the RKE2 cluster and do a kubectl apply. Simple. Now, preparing RKE1 cluster for migration. We are not there, we haven't backed up yet. We are not there yet, we are still preparing for the migration, right? Now deploy sample app on RKE1 cluster. Why? Because we wanted to run smoke tests, right? Dave has already mentioned that we have built a test suite that's in PyTest, and this is a sample app that we have written again, that's in Python. What it does is, it pulls the secrets from a particular location, it sends logs, it has certificate management, it's a prod grade application but it's a test application. When we take the backup here, once we restore on the RKE2 cluster, all the functionalities of the RKE2, whether it met our success criteria or not, are validated using this app. So that's why we wanted to, we had deployed this app onto the RKE1 cluster beforehand to run smoke tests afterwards. Now, we have different sorts of environments, non-prod, prod, dev, and stuff like that, right? And that's, in non-prod, in dev, people tend to experiment, the pods will be in not running state, it will be in crash looping and whatnot, right? When we take the backup and when we restore it, it will be in the same state, and we don't know whether that's a restoration problem, whether that's something that's missed by us, or whether it's an application problem. That's another variable. We don't want it. So what we did was, whatever the action, we'd be deleting the pod if it's a pod object, or if it is a deployment or replica set, scaling down, whatever that object takes for it to be removed, we made sure that all bad pods are not there. This means whatever we take a backup, it's a good backup, and when we restore, the expectation is all of the apps should be up. Another thing is we have to do the data migration also. So for the data consistency, after we take the backup, if application is still writing, that's not good, no good. It's inconsistent data. So in order for us to migrate the data and have the data sanity, scale down all the pods that are associated, or the objects that are associated with the PVCs, so that we know at the time of the backup, now we got the right backup. Now creating the restore location, this is basically establishing the connection with Velero to the S3 so that we could store our backups there, and the same S3 location will be used in the RKE2 cluster to pull and restore. Now finally we arrived at backup, right? The crunch, or basically the meat of it. Now here the question is, which tool should we use, right? Should we use one big backup for all the namespaces? Should we use backup for individual namespaces? Does the tool that we use for the backup, can it also handle the volume backup? These were all the questions that we have, and I think Velero checked most of our checkboxes, and we decided to use Velero. And for the sake of easy rollbacks and easy tracking, we decided not to do a big backup, and in case of failure, it's difficult to track which namespace it failed on, which object it failed on, and stuff like that. We decided to do backups at individual namespace level, so that if they fail, we know which namespace it failed on, and we could retrigger our pipeline from that particular point. So that was one of the reasons why we had to do small names or backup per namespace instead of one big backup. And that's just that. Can you click on it, Dave? That's how it goes from that cluster to S3, and then one more click, Dave. And then for the volumes, we used Velero vSphere plugin. So our CSI driver is vSphere CSI driver. So luckily, we have a Velero plugin for vSphere that kind of deploys couple of components called backup driver and data mover. The backup driver kind of monitors the backup object, and when there is a new backup object triggered that has a volume in it, it talks to the vSphere, it prepares the volumes, and the other component data mover moves it from one moves it from vSphere to wherever it is configured, right? In our case, it's S3. The key challenge here is it takes the backup of the entire volume. Say we have requested 100 GB, but our utilization is 10 GB. It doesn't take 10 GB, it takes 100 GB, right? So, and it is also by default designed to do one at a time. It can do concurrently, but that gets difficult to again track down which failed, what failed. Again, if you have to trigger restore, that's difficult. So the concurrency part of it is available. It can do up to 4, but we haven't used it. We used 1, which is a standard and recommended thing, and it's easy, right? And if you guys don't have a CNI or CSI driver that is backed by Velero, there is a Velero CSI driver that is available, that is generic, that can also be used, but what I read, this is read, we haven't used it. What I read is it kind of takes a little bit more time. After we have all the backups that are along with the volume sent to the S3, now it's time for all the applications to shut down, right? Now, because we didn't have enough capacity, I would say, or we were smart enough to say like, okay, we will bring down the RKE1 worker nodes now. This is where the actual application downtime starts. Until now, we are in the migration process, but the applications were still up except for the PVC ones. Rest everything was up so far. Now, once we bring down all the RKE1 worker nodes and bringing up RKE2, because we turned off autoscaler on RKE2 just to make sure it is like to like. So now it's our turn to manually scale up RKE2 clusters to match the RKE1 count. Here, if you guys don't have the capacity concern, subnet concern, whatever it is, you guys can pre-scale them too. But this is where basically we just scaled up our nodes. And here we used Go to concurrently do it so that it was quick enough for us to spin up the nodes. But if your autoscaler can do it quicker, then maybe you can use autoscaler too. That's a choice of yours. And then create the restore location on RKE2 cluster to match the same of RKE1 so that it can pull the backups and restore it. This is all of the things that we have done so far is only for this, restoring objects onto the RKE2 clusters, right? What we did, because we did all of it, now I don't have to talk much about it. All we did was we downloaded the backups onto the RKE2 cluster. We did restore them sequentially one by one because we also have a component of data which only can be done one at a time. So all the namespaces that does not have the data are good, very quick enough to be restored. But the ones that have the data, that's variable, say like how many volumes are there, what is the volume of each data and stuff like that, that is variable. But all we had to do was submit and just wait for it to do its thing. Once all the once all the objects are restored, Velero has some statuses that it can show us, and we used that to match whether all the objects that are backed up are restored or not. That we can check all of those using the Velero statuses and make sure everything that's there in the backup is restored, right? That's what we checked. This is just again nothing. That's how it went. And friends, that's how all of our applications met RKE2, right? Now, good, we have our applications on RKE2. How do we access them, right? That's what the part is. So the good thing is, like Dave mentioned, we have a static load balancer in front of our ingress and we use wildcarded DNS. So now our load balancer has the RKE1 workers as a pool. Now what we did was we added RKE2 worker nodes into the same pool so that the applications are now accessible using the same, and we removed the RKE1 worker nodes. It's as simple as that. Having a static load balancing endpoint beforehand gives us a lot of control, and what we did was just adding the members of RKE1, RKE2 into it and removing it. It's just the pool member management at the end, nothing difficult, right? But now, okay. Yeah, so after that, our promise was no changes to the application, right? Meaning application team should be able to still access their stuff using the old rancher manager endpoint. How we did that? We pointed out, we related the A record for the old rancher and manager endpoint, and then we pointed it out to the newer one, alias, so that they could still use the old endpoint but are pointed now to the RKE2 clusters. And another important thing is the project IDs are different, right? The namespaces are good, are restored, projects are created, but RBAC is messed up because the IDs are different. What we had to do was, we had to, this is all again in the pre stuff which I forgot to mention, we also gathered the which namespace is part of which cluster name, and then we mapped it back so that the RBAC for the teams to be able to log in and do the stuff for the validation is all set too, right? Once all of that is done, we invited our application teams, our smoke test was also good too, and once all of it is done, everybody was happy. Their applications were moved with none of their involvement, right? But it is not that easy. We didn't figure out all of it at once. These are the things that are our learnings and probably could help you guys as well, right? So, like Dave was mentioning, I'll start with the last one first, retrospectives and continuous improvements. We did it over 6 weekends. First weekend was a mess. We didn't know a lot of things that all of it I talked about before. We couldn't figure out all of it. We broke, but we moved forward learning some of the things, and those things are the ones that are starting from the first.
I'll just say one thing on that, and interrupt Karthik, is that one of the retrospective goals was to have a bookkeeper, which usually was me, which was we were tracking every single thing that broke, how it broke, why it broke, and what we think we needed to do to fix it. So, because like you're in the middle of a change, right? You're trying to solve problems and fixing things. So we wanted to make sure we had an accurate record so that when Monday came around after that long weekend, we started coding and fixing all those things for the next weekend. So it was like a marathon. So go ahead.
Yep. And now the lessons that we learned are probably that you could take from us. Inspect all objects created using Rancher UI in RKE1 clusters and make sure those features are still existing. What I mean by that is, I'll give you an example where we failed here, right? Rancher has a concept called project level secrets, right? Where we used to have a concept called project level secrets, where if you create a secret at the project level, it will be populated to all the namespaces. That does not exist anymore. But our clusters were built much before, and people started using that feature. We didn't know because we don't use it. As a platform team, we prefer CLI, APIs, and stuff like that. But there are people who use it using UI, right? We didn't know. We didn't account for it. But when we restore on RKE2, surprisingly, those secrets were missing because a controller in RKE2, if it finds a certain annotation, is removing those secrets. We didn't know about it. So inspect any of the objects that are created using UI and make sure those features are still intact. That's one of the lessons. Second thing, restoring statuses of the CRDs needs additional processes other than Velero. What do I mean by that? And here again our learning is, we use Argo, and it has lot of CRDs that it uses, like rollout status and stuff like that, that needs the history. After the restore, it also should have the history of the deployment and stuff like that, and Velero does not do a good job in restoring the CRD statuses. So that's another lesson. We failed there, but we learned, and we added an additional process of, if there is a CRD where we need the statuses to be restored, that's an additional process that we added into our migration. And review all CRDs allowed in the vSphere Velero plugin. If you are using vSphere Velero plugin, that also has an allowed list and blocked list. Ensure that those are matching. Basically, when I say those are matching to your requirements. And then inspect all cluster scoped objects thoroughly, as there is difference between RKE1 and RKE2. Like I was mentioning, there are decent amount of differences between the CRDs, and we don't want to carry the tech debt onto the RKE2, right? We want it to be a clean slate, so just make sure you inspect and bring in what's good, right?
That one's a big one.
Yeah. Containers can behave differently between C group V1 and C group V2. Nothing to do with RKE1 and RKE2. this is not something to do with RKE1 or RKE2. This is between the Ubuntu or operating system versions. Earlier, before migration, we were running on Ubuntu 20, and post migration, our RKE2 was built on Ubuntu 22. And if people does not define the values and left it to the defaults, the interpretation of C group V1 is different from interpretation of C group V2.
Particularly in Java.
Particularly in Java.
Really old Java apps that just folks weren't rehydrating properly, and when those apps were coming up, they weren't respecting the defaults that were set, and they were just running into like out of memory conditions like repeatedly. So
Yeah.
we had to actually hard code them and define them.
Yeah, but if you, that's one thing, if you make sure that the defaults are not left to defaults, they are configured, right? That's the lesson there. And next thing is about the Helm hooks. Velero takes the snapshot of what's there in the cluster and restores it, but if we deploy it using Helm, we probably run a job beforehand to do something else before the pod comes up, right? It's like pre-setup, talk to something else, and do something else before the pod comes up, right? If there is any such requirement, if your application teams are using Helm hooks actively or post any of it, make sure those are audited, and if you find it, whatever those are using, you have to run an Helm upgrade on top of it to make sure everything else is respected over and above the Velero. And finally, again, retrospective.
Thank you very much for coming. If you have any other questions, we'll be outside, or you can ping us and we'll be happy to help.